Everyone. The topic is about unit operation food processing, which is about introductions in unit operation in food processing. Outline. In this, we'll be seeing about what is unit operations, what is material and energy balances, and what is material handling and related preliminary operations. In first one, what is the basic principles of unit operations in food process engineering? Unit operations, it is the process of engineering. It is an attempt to combine all forms of physical processing into a smaller number of basic operations, which are called unit operations. Food processes may seem bewildering in their diversity, but careful analysis will show that these complicated and different processes can be broken down into a simple number of unit operations. For example, consider heating of innumerable instances occurring in every food industry. There are many reasons for heating and cooling, for example, baking of bread, freezing of meat, and frying of yam slices in oils. But in process engineering, the prime considerations are firstly the extent of the heating or cooling that is required, and secondly the conditions under which this must be accomplished. Thus, this physical process quantifies or qualifies to be called a unit operation. Units and dimensional analysis. All engineering deals with definite and measured quantities, and so depends on the making of measurements. To make a measurement is to compare the unknown with the known. For example, weighing a material compares it with the standard weight of 1 kilogram. The result of the comparison is expressed in terms of multiples of known quantity, that is, so many kilograms. Dimensions. These dimensions include length, mass, time, and temperature. For convenience in engineering calculation, force is added as another dimension. Force can be expressed in terms of other dimensions, but it simplifies many engineering calculation to use force as a dimension. Example: weight equals mg. Dimensions are represented by symbols, which is length L, mass m, and time t, and temperature capital T, and force capital F. Note that these are enclosed in square brackets, which are the conventional way of expressing dimensions. Units. Dimensions are measured in terms of units. For example, the dimension of length is measured in terms of length units like micrometer, millimeter, meter, kilometer, etc. So that the measurements can always be compared. The units have been defined in terms of physical quantities. For example, the meter m is defined in terms of wavelength of light. The standard kilogram kg is mass of the standard lump of platinum iridium. The second S is the time taken for light of a given wavelength to vibrate a given number of times. Material and energy balances, which is lecture 2. Material quantities, as they pass through food processing operations, it can be described by material balances. Such balances are statements on the conservation of mass. Similarly, energy quantities can be described by energy balances, which are statements on the conservation of energy. If there is no accumulation, whatever goes into a process must come out. This is true for batch operation. It is equally true for continuous operation over any chosen time interval. Material and energy balances are very important in the food industry. Material balances are fundamental to the controlling of processing, particularly in the control of yields of the products, and needs to be reviewed periodically. Basic principles of material, which is mass and energy balances. If the unit operation, whatever its nature, is seen as a whole, it may be represented diagrammatically as a box as shown in figure 1. The mass and energy going into the box must balance with the mass and energy coming out. This is the box in which the row, this is the mass and energy balance. In this, the energy, which is heat, work, or chemical or electrical work, and the feed materials, it is converted as stored material, stored energy, and it is released as products out, waste products, energy in products, energy in waste, and energy lost to surroundings. This is the diagrammatic sketch of mass and energy balance. In this, what comes in must come out. Material handling and related preliminary operations. At the time of harvest or slaughter, most food are likely to contain contaminants, to have components which are inedible, or to have various physical characteristics. For example, shape, size, and color. It is therefore necessary to perform one or more of the unit operations of cleaning, sorting, grading, and peeling to ensure that foods with a uniformly high quality are prepared for subsequent processing. Cleaning. Cleaning is the unit operation in which contaminated materials are removed from the food and are separated to leave the surface of the food in a suitable condition for further processing. Peeling fruits and vegetables, skinning meat, or descaling fish may also be considered as cleaning operations. In vegetable processing, blanching also helps to clean the product. The presence of contaminants or foreign bodies in processed foods It is the main cause of prosecution of food companies. Cleaning should take place at the earliest opportunity in a food process to prevent damage to subsequent processing equipments by stones, bone, or metals, and to prevent time and money from being spent on processing contaminants which are then discarded. Types of cleaning. First is wet cleaning and dry cleaning. Wet cleaning is more effective than dry cleaning methods for removing soil from root crops and or dust and pesticide residues from soft fruits and vegetables. It is also dustless and causes less damage to the foods than dry methods. Different combinations of detergents and solvents at different temperatures it allows flexibility in operation. Dry cleaning. Dry cleaning procedures are used for products that are smaller, having greater mechanical strength and possess a low moisture content. For example, grains and nuts. After cleaning, the surfaces are dry to aid preservation or further drying. The main group of equipments used for dry cleaning are air classifiers, magnetic separators, separators based on screening of foods. Sorting. Sorting is the separation of food into categories on the basis of a measurable physical property. Like cleaning, sorting should be employed as early as possible to ensure a uniform product for subsequent processing. The four main physical properties used to sort foods are size, shape, weight, and color. Then grading. This term is often used interchangeably with sorting but strictly means the assessment of the overall quality of a food using a number of attributes. Sorting, that is the separation on the basis of one characteristic, may therefore be used as a part of a grading operation but not vice versa. Grading is carried out by operators who are trained to simultaneously assess a number of variables. For example, eggs are visually inspected over tungsten lights called candling to assess up to 20 factors and remove those that are, for example, fertilized or malformed, and those that contain blood spots or rot. This is grading. Mechanical separation. Mechanical separations can be divided into four groups: sedimentation, centrifugal separation, filtration, and sieving. In sedimentation, two immiscible liquids or a liquid and a solid differing in density are separated by allowing them to come to equilibrium under action of gravity, the heavier material falling with respect to the lighter. This may be a slow process. It's often speeded up by the applying centrifugal force to increase the rate of sedimentation. This is called centrifugal separation. Filtration is the separation of solids from liquids by causing the mixture to flow through fine pores which are small enough to stop the solid particles but large enough to allow the liquid to pass. Sieving, interposing a barrier through which the larger elements cannot pass, is often used for classification of solid particles. Sedimentation. It uses gravitational forces to separate particulate material from fluid streams. The particles are usually solid, but they can be small liquid droplets, and the fluid can be either a liquid or a gas. Sedimentation is often used in the food industry for separating dirt and debris from incoming raw material, crystals from their mother liquor, and dust or product particles from ash streams. In sedimentation, particles are falling from rest under the force of gravity. Centrifugal separation. The separation by sedimentation of two immiscible liquids or of a liquid and a solid depending on the effect of gravity on the components. Sometimes this separation may be slow because the specific gravities of the components may not be very different or because of the forces holding the components association, for example, as occur in emulsions. Sieving. In the final separation operation in this group, restraint is imposed on some of the particles by mechanical screens and prevent their passage. This is done successively using increasingly smaller screens to give a series of particles classified into size ranges. The fluid, usually air, can effectively be ignored in this operation, which is called sieving. The material is shaken or agitated above a mesh or cloth screen. Particles of smaller size than the mesh openings can pass through under force of gravity. Rate of throughput of sieves are dependent upon a number of factors: nature and size of the particles, frequency and the amplitude of the shaking, method used to prevent sticking and bridging of particles in the aperture of the sieve, and tension and physical nature of the sieve material. Next, from the next class, up to sieving, we have discussed all the topics from what is unit operation, what are the dimensions, what is energy and mass balance, and what are the various steps from sedimentation, centrifugal separation, filtration, and sieving. In the next section, we'll be seeing about contact equilibrium process. Thank you.